going to continue with alkenes. A little introduction of alkenes we have already done, that they are going to be unsaturated hydrocarbon, means they have carbon and hydrogen, hydrocarbons. Unsaturated means they are going to have carbon-carbon double bond inside. And all the bonds are covalent. Sharing of electron is going to happen. General formula for alkenes is going to be CnH2n, means any n value you can put over here and you can get the formula. So hydrogen number is going to be double of carbon number. And remember one thing over here, that n number we can put at least 2 onward. N number 1 is not possible in alkenes, as we know that at least one double bond should be there, means 2 carbons should be present. So minimum n value that we can put in the formula should be 2. Okay, then because they have double bond inside, double bond means one of the bond from the double can break and every carbon can attach one thing extra. So that is the reason they are going to show some reactions as well. So we will see some reactions for the alkenes. Before that, naming of the alkene and everything is already done. Displayed formula and the structure. This thing we are not going to see for now. We are going to move towards the method to prepare alkenes and then reactions. To make alkenes, one method is that we did in case of the crude oil. Crude oil is basically a mixture of many different oils and fuels together. We said that we can separate all the fractions easily by using the fractional distillation method. And fractional distillation method is going to work depending on the boiling points. So we are going to heat the crude oil. According to the boiling points, all the fractions of the crude oil are going to separate from each other, right? So crude oil is giving us alkanes basically. When we are separating the fractions in the fractional distillation, it is going to provide us all the alkanes. And if you remember, we said that we are going to get the alkanes starting with carbon number 1, 2, 3 till maximum carbon number 70 or sometime above 70 as well. So these alkanes, which are basically having higher number of carbon atoms, like 30, 40, 50, 70, they are less useful. Okay, so carbon number like maybe 20 onward till 70, or in other words, simple what you can say, like the hydrocarbons or alkanes which have more carbon atoms or longer chains of carbon, they are less useful. Okay, and starting alkanes which have less number of carbon, like carbon 1, 2, 3, 4, 5 till 4, 5 basically, they are more useful. But in case of the crude oil, we are getting all. We are getting the carbon 20, 30, 40 till 70 all. So it means we are getting the less useful alkanes as well. And we are getting these less useful alkanes more than needed. We need smaller alkanes more, but we need larger alkanes in less quantity. But we are getting them more than needed. So what we can do? Any idea which comes in your mind, if we have these alkanes which are smaller, they are more useful, the bigger ones are not useful or very less useful. Any idea that we can make these less useful alkanes more useful as well? Yes, Luna.
Miss, we can do one thing that we can break them down into smaller carbons to like alkanes to make them more useful if possible.
Okay, right. Yes, Wafia.
Miss, would it be possible to use like some specific processes to, break down the
Hmm.
alkanes that have like a higher number of carbon?
Hmm.
Could we like
Right.
break up the bonds between the carbons? So,
Hmm.
just add another hydrogen or something and,
Right.
process it.
Hmm.
Yeah.
Right. Both the answers are correct. Yes, we can break the larger one into smaller alkanes, which are more useful. So for this, we use a method which is known as catalytic cracking. So catalytic cracking method is used to convert longer chain molecules, the larger hydrocarbons, alkanes, to the short chain alkanes, which are more useful. Okay, so when we are going to break them, we are not going to get only alkanes. When we take the alkane and we try to break it, the longer alkane can give us three different products. It can give us a short, let's say you're taking a long alkane and you're going to break it. It can give us short alkanes after breaking, or it can give us alkene as well. And when it is giving us alkene, we can also get hydrogen gas as a product. So we'll see when these products are possible. I will tell you when any product is possible. So we have three different possibilities for the product. When we break the longer alkane, we may get a short alkane, we may get alkene or hydrogen gas. And now these short alkanes, alkenes, and hydrogen all are useful. So we can use them all. So we can see some of the uses and then we'll see when we are getting these products. When we break them, we are getting short alkanes, alkenes, and hydrogen. Okay. Alkenes we can use to make polymers. We will talk about polymers in detail, but to make the polymers, alkenes are needed. And the hydrogen gas that we are getting from here will be used to make ammonia, which is also very useful. So means all the products now will be more useful. Okay. Yes, Umama, any question?
No, miss.
Okay. So, for example, let's say we have kerosene and diesel oil. They are large alkanes and they are not much useful. So we can crack them, break them, and we can get petrol, small alkane. We can get alkene or maybe hydrogen as well. Alkenes are used to make polymer. Hydrogen is used to make ammonia. So all the product will be now more useful. Okay. Now, how we can do this cracking process? Cracking is basically a heating process in which we have to heat the hydrocarbon molecule to break the bonds and break the structure into smaller pieces. So, cracking is heating the hydrocarbon molecule at very high temperature, about 600 to 700 degrees Celsius. And by this, it is going to change into, first of all, vapors. Let's say the larger alkanes are definitely going to be liquid or thick liquid. So we are going to heat them at 600 to 700. First, they will convert into vapors. After converting into vapors, they will break the bonds. How? We are going to use a catalyst as well, and catalyst should be hot powder form because powder form of the catalyst will react more as compared to bigger pieces. Okay, so powder form of the catalyst, for example, alumina or silica are the two different catalysts that we can use over here. These vapor forms of the larger alkanes, they will pass over the powder form of the catalyst and the bonds will break. Okay, how? We will be having powder form of the catalyst, very hot. So these vapor forms of the alkanes, they will come into contact with the surface of the catalyst and the catalyst will help them break the covalent bonds in the structure because heat and catalyst is helping over here to break the bonds. So we can say it catalytic cracking, catalytic breaking, or heat is also used up, so we can say it thermal as well. So it's a thermal decomposition reaction or catalytic cracking reaction. Okay. Any question till here? Yes. Yes, Wafia.
Miss, what's alumina?
Alumina or silica are basically the names of the catalyst used.
So
Alumina is
is it
aluminum
re
oxide, silica is
Oh,
silicon
okay.
oxide. So these are the
Oh, okay,
oxides of
okay.
aluminum and silicon.
Oh,
So their
okay. Thank you.
name is alumina and silica. Okay.
All right, thank you.
Okay. So here we are using hot and powdered form of the catalyst. Why we are using the powdered form? Any idea why the powder form of the catalyst is going to be more useful than the catalyst itself, like the bigger piece of the catalyst? Yes, Jude.
Yes, miss, because if it's just one solid, it's not powder form, there won't be enough surface area, but the powder increases the surface area, so there is more reaction because the reactions happen in the surface of the catalyst.
Right? Because powder form means it is going to have more surface area. So surface area more means the reaction is going to be more as well. Okay, Samreen, you can also tell what's your idea why we are using the hot powder catalyst basically?
Miss, basically the same point. First of all, the whole temperature will increase the rate of reaction, and also the large surface area will also increase the rate of reaction.
Right. So heat is going to increase the reaction plus powder form means bigger surface area will be there, so more surface area will speed up the reaction. Okay. So we said catalytic cracking method or thermal decomposition as well. Catalytic cracking is a type of thermal decomposition, right? So in the exam, they can give you this cracking reaction and they can ask you, is cracking addition reaction, substitution reaction, or thermal decomposition reaction? So it's a thermal decomposition reaction. Okay, so like this, they can ask you type of reaction as well.
Miss, I have a question.
Yes, Luna.
Miss, for this process to happen, there are specific machines, right? Specific machines.
Yes. Hmm. There
Okay,
is
just ask.
big burners. Basically, we are going to have big machines in which we can easily achieve this temperature and we can do the catalytic cracking.
Miss, can you show us, if possible, a picture of it and how it's done? If possible, a video or a picture of how it's
Okay,
really
sure.
done.
After this class, I will show you or I will send you as well. Okay, for the catalytic cracking. Okay, so for the catalytic cracking, because it is going to happen randomly, it is going to be a random method. Random means, let's say you have 20 carbons, so they can break randomly. Maybe they can break into two pieces of 10 carbons. They can break into two pieces of 15 carbon and 5 carbon, 17 carbon and 3 carbon. So we cannot control the length of breaking. It is going to happen randomly. Okay. So when it is going to happen randomly, it means we are getting a mixture of the products. In one breaking, we may get different multiple products with multiple carbon lengths. Okay. And if we want to get the hydrogen or alkenes, then we need to provide little higher temperature and pressure. Let me show you one of the example, then it will be more clear to you. Let's say you're taking decane means with 10 carbon alkane and you are going to provide heat to do the cracking reaction. It is going to break, let's say, into two of the products over here. One is going to be 8 carbons and 2 carbons separate. Okay. As I told you, it's a random process. It can happen 2 and 8, 3 and 7, 4 and 6, 5, 5, or maybe all at one time. Because there is not going to be one molecule of decane, one compound of decane. Many decanes are there inside, right? So all can give us multiple products at the end. Okay, so in this case, we are getting an alkane and ethene, one of the alkene. So we are getting alkane and alkene. Why we are not getting hydrogen over here, or in what case we are getting hydrogen? Let me tell you. Okay, see, we have C10H22. We are getting octane and ethene over here. We know if we just try to write the formula of octane, it should be 8 carbon, 8 2 times 16 plus 2, 18 hydrogen, right? Then we are getting one of the alkene, ethene, its formula is 2 carbon, 4 hydrogen. So these two together, when you add them, it should give you the main formula back. 2 carbons and 8 carbons are total 10 carbons. 18 hydrogens and 4 hydrogens over here is going to be total 22 hydrogens. So separate hydrogen is not going to be possible over here. Okay. So in what case we can get hydrogen? If we get, let's say, not alkane over here. If we get alkene over here, not octane, let's say it is octene. We are getting, let's say, alkene, ethene, or maybe we are getting octene with it. So now the formula, what will be the formula of octene? 8 carbons with how many hydrogens? Octane, 8 carbon alkene. What should be the formula? Yes, Wafia.
Miss, 8 carbons And 16 hydrogens?
16 hydrogen. Hydrogen will be just double of carbon, right? Okay, so we are getting 8 carbon, 16 hydrogen, and the second thing we are getting over here, 2 carbons, 4 hydrogen, right? Okay, if we add, which is basically ethene over here, if we add these together, is it going to give us the same formula back, Luna?
Miss,
Let's say we have decane and I'm breaking two pieces of, I'm making two pieces of the decane. I'm getting one octene, one ethene. 8 carbon and 2 carbons, 16 hydrogen and 4 hydrogen. Is it giving me back the same formula just like decane or something is
no,
missing?
no, Miss. 2 hydrogens will be needed.
2 hydrogens will be needed. So yes, it can give us hydrogen gas, right? Because 2 hydrogens are not added in the formula. So these 2 hydrogens, 16 and 4 hydrogens will be 20. 2 are still needed. So it means hydrogen gas will be produced in that case. So in other words, what you can say over here that when you are going to crack an bigger alkane, you may get a small alkane with alkene, then there is no hydrogen. Okay. Or if you have a bigger alkane and you are going to break it, if you're breaking it into alkenes, then hydrogen will be produced. Okay. So like this, multiple products will be there. If you're getting alkenes, or one alkene maybe, or two alkenes, let's say, alkene means there is going to be two hydrogens less now. Then hydrogen gas will be there. So like this overall, alkane, alkene and hydrogen, three are the possible products. How the question will come in the exam? They will not ask you to break it into anything or make this, whatever. They may ask you, let's say that there is a decane and we are going to get a pentane and a pentene. So write the formulas or complete the equation. Or maybe they can ask you to complete the hydrogen carbon number on both sides of the equation if you have to balance the equation or something like that. We'll see some questions from this topic as well. We have some hands raised. Any question, Luna and Wafia?
Miss.
Yes,
Yes.
miss. Oh,
Yes, Luna, any question?
Okay, Miss. So basically, as we see in this example, that decane has been divided to octane and ethene. And then in the other example, alkane is
Hmm.
also divided to alkene and hydrogen. Miss,
Hmm.
like I got a suggestion or some kind of a smart idea that
Hmm.
we have alkane and then divided to alkane and alkene. Miss, we can do one thing that you
Hmm.
did, that we divided to we had we can do one thing that the octane we did it to alkene,
Hmm.
that both alkene and with the machine, and then we got the hydrogen. So did we
Hmm.
do this like this?
Yes, we can do both
So
ways. Let's say in the exam they're asking you to make hydrogen from cracking. Then definitely you will add alkene, the other product, and hydrogen. Because with alkene, hydrogen will not make. Okay? Or in the exam they're asking you that you have an alkane, break it into any alkane or alkene, any number of carbon. So then you can make alkane and alkene, no hydrogen. So according to the requirement, we can break it. We can write the equation accordingly. Okay.
okay,
But one thing that you have to remember, which is the key over here, that whatever is the carbon number or hydrogen number in the reactant should be the same in products, all the products together. Carbon should be same in the reactant. Let's say reactant has 10 carbons, all the product together should be 10 carbon. Reactant has 22 hydrogens, all the product together should be 22 hydrogens. This number should be balanced when we are breaking it into pieces. Okay. Yes, Wafia and then Samreen.
miss, my question was that, when we break
Hmm.
a huge alkane into two separate, substances using catalytic cracking, Is it a reversible reaction or is it irreversible? So my question is basically, is
Thermal
there another
decomposition,
process that
it is not going to be reversible reaction. Okay. If we want to do the reverse, then we have to do another process. We have to collect the products, then we have to do it reverse, which is not easy. So it's not a reversible reaction.
Oh,
Okay.
okay. Yeah, all right. Thank
But
you.
there is one thing that I will tell you in this reaction, which is a very important exam question. Before that, we'll take Samreen's question. Yes, Samreen.
Miss, thermal decomposition and catalytic and cracking, they are the same thing, right?
They are the same thing for now. Why? Thermal decomposition can happen anywhere. Wherever the substance can break with heat is known as a thermal decomposition reaction. It's a general term. Okay? Catalytic cracking means we are breaking alkane into smaller pieces. This is a specific word for only alkanes.
Okay, miss.
Thermal decomposition is a general term we can use for many reactions. Whatever reactions are breaking with heat, they are known as thermal decomposition reactions. And catalytic cracking is one of the example of thermal decomposition reaction. It is only for alkane. It's specific to alkane.
Okay, miss.
Like this. Okay, one thing important over here. In the exam, they can ask you, okay, you have a decane, you want to break it, and we want to get octane and ethene. Is it possible to get pure octane and ethene at the end of reaction? So question is it possible to get a pure product at the end of catalytic cracking reaction? Any idea from your side if you want to answer it, otherwise I will tell. Is it possible to get a pure product at the end of the catalytic cracking reaction or no?
Miss, what do you mean by pure product? I don't really
Pure means
understand the
nothing
question.
else will be produced. We are just getting octane and ethene. Nothing else is possible. Like I'm taking decane, I'm going to do the catalytic cracking, and I'm getting just octane ethene, nothing else. Yes, Judith.
Miss, I think it may be possible, but most probably I think no, because
Hmm.
any impurities from the air might get inside it, and also the use of the catalyst. Maybe the use of the catalyst might give us, other products, or some of the catalyst itself might be still in the products.
Hmm. Okay. Yes, Wafia. Jude, your point is fine, but I will add something over here. Yes, Wafia.
Miss, I'm not sure, but I don't really think that another product would be produced because, it's just carbon and hydrogen, so it's just gonna break into its,
Hmm.
respective alkane
Okay.
and alkene. I'm not really sure though.
Okay, fine. Let me tell you. Jude, your point is fine according to the impurities, like anything can from the air can add or whatever. Impurities we can somehow control. But still, this reaction is never going to give you a single product or pure product. Why? As I just told you, the breaking is going to happen randomly. Decane means total 8 carbons are there, 22 hydrogens, right? This 8 carbon can break into maybe, decane means 10 carbon. 10 carbons are there, right? This 10 carbon can break into maybe 5 carbon 2 pieces. May at the same time it can break into 7 and 3 pieces. At the same time it can break into 2 and 8 carbon pieces. It can break into 4 and 6 carbon pieces. It can give alkenes with hydrogen. Multiple products are possible. Okay, this is one of the example that decane can break into these two pieces. This is not the only two pieces, because many molecules of the decane, many compounds of the decane will be there. They are going to give us many possibilities at the end. So this catalytic cracking is never giving us one type of the product only. It will be having a mixture of products inside. Then we can separate all the products from each other depending upon their boiling points by fractional distillation method or whatever. Okay, but a mixture of product will be produced at the end. That's what they said over here. The molecules are broken up in a random way and it is going to produce a mixture of smaller alkenes with hydrogen gas. Okay, any question? Yes, Samreen.
So, Miss, isn't this pure? Because at the same time, sometimes it can produce five and five pair like that.
Pure means no other possibility, only a single product we are getting.
Oh, okay,
So
Miss.
it's not pure, it's not a single product. We are getting many possibilities. A mixture of products. Mixture of product means a range of boiling points, a range of melting points will be there.
So, Miss, if we have range of possibilities, that means it is impure.
It is a mixture, it is impure. Mixture means something impure, which is not
Okay,
single product. So we're getting a
okay,
mixture of alkenes and alkenes at the end. We're not getting one single product. So if they ask you that we want to just get pentane, do the cracking and get a pentane. Is it possible? No, we cannot get just a pentane. We will get a mixture of products. One single product is not possible by cracking reaction. Okay. Any question?
okay,
We
Miss.
still have Wafia and Luna. Hand raised. Any question, girls?
Oh no, nothing, Miss.
Yes, Miss.
Yes, Wafia.
So Miss, in catalytic cracking, all it's doing is breaking up the carbon bonds. It's not going to like separate the
If you
products.
break only, then we need to do further step to separate them because a
So
mixture
fractional
at the
distillation.
end. Then we can do fractional distillation, some other methods as well. So we have to separate them.
Oh,
Okay,
okay.
so it is going to break and give us a mixture at the end. Okay, okay, let's move forward. Now we know the difference between alkane and alkenes. Alkenes have carbon-carbon double bond inside. Alkane does not have carbon-carbon double bond. They have single bond. And we said that in alkanes, the carbon-carbon single bond is unreactive or it is not going to have addition reaction. It will have substitution reaction, combustion reaction, not addition. Addition means it cannot add anything on the carbon. But in case of the alkenes, when they have carbon-carbon double bond, they can have addition reaction. What does mean by addition reaction? Addition means, let's say, if I give you example of an alkene having 2 carbons, 4 hydrogens. Okay, I want to add bromine on it, Br2. What will happen? This alkene will break the double bond to single. Okay, when it is breaking the double bond to single means now both the carbons have total 3 bonds only. They can add something on it, means they can make one bond over here, one bond over here. So this bromine, one Br can add on this carbon, one Br can add on this carbon. So this is called addition reaction. Okay, but in case of the single bond it is not possible. It's already single. It cannot break one of the single bond and can add something on it. So that is the reason single bonds don't have addition reaction. Double bond alkene have addition reaction. They can break the double bond, add something on both the carbons. It can be bromine, it can be anything else. We will see some reactions about addition. For now, because alkenes can add bromine, alkanes cannot add this bromine. So means they are different. We can use this bromine addition as a difference point between two. Okay. This bromine at the start is basically orange in color. Okay. Let's say you have alkene and you are going to add bromine in it, which is orange color solution. As soon as the bromine add, its color is going to disappear. So final thing that you are getting over here is going to be colorless. So this test we can use to identify something unknown. Let's say I'm giving you a beaker and I'm not telling you is it alkane or alkene. I'm asking you to do a test and just find out is it alkane or alkane. What you can do? You can add some bromine inside. If the bromine color brown or orange changes to colorless, it means there is alkene, which is adding the bromine changing the color. If the color is not going to change means the bromine is not adding, it means there is no double bond inside, so it means you have alkane at that time. Okay, so this bromine will come mixed in the water, aqueous, so we said bromine water. So what we can do to check the presence of carbon-carbon double bond, we can add bromine water. Bromine water is orange color at the start. It will changes color later on. If alkane will be there, there will be no color change. So if I show you the solution, how it will look like, with the alkane, it will remain brown. It is not going to change the color, remain brown or orange, but with the alkene, it is going to change. It will become colorless at the end. So shaken with the alkene, the solution will go colorless. Okay. Yes, Wafia. Any question?
Yeah, Miss, I think your voice glitched for me when you were explaining something about the displayed diagram on the previous page with the bromine and carbon
Okay,
and
so basically I
hydrogen
was
and all
telling
that.
that,
So,
yeah, basically I was telling that double bond can break to single and it can add something on both the carbons. Because when it is breaking means both the carbons have the ability to add one thing again. So addition reaction is possible when we have alkenes. Okay, so bromine is orange in color. As soon as it is going to add on the double bond by breaking it, it will change to colorless. So alkenes can do the reaction with bromine, change the color from orange to colorless. Alkanes cannot do this reaction, so solution color will remain orange. So this is one of the tests to see the presence of carbon-carbon double bond. Because carbon-carbon double bond is also called unsaturated. So this is basically a test for unsaturation. In the exam, it can ask you that explain a test for unsaturation. Unsaturation means presence of carbon-carbon double bond. So you can say that to check the presence of double bond or to see unsaturation, we can add bromine water. Bromine color changes from orange to colorless means there is unsaturation, there is double bond present. Otherwise, there is single bond. So like this, we can do this test. Okay. And
Can you repeat, Miss? I'm sorry, Miss, but can you repeat for me the unsaturated one?
yes,
I
yes.
couldn't get.
Unsaturation means unsaturated compounds or hydrocarbon means those which have the carbon-carbon double bond inside. Saturated means having only single bond. So if
Miss,
you want to,
why? Why? Like
why
specifically?
unsaturated we did in the homologous series. Unsaturated hydrocarbon means those which have carbon-carbon double bond. Saturated hydrocarbon is the one which has carbon-carbon single bond. Okay.
Yeah, yeah. I remember.
So
Okay.
saturated means which has carbon-carbon single bond. So if you want to find out that a solution is unsaturated or means it has carbon-carbon double bond, we are going to add bromine. Bromine will add on the double bond, changes the color, means unsaturated solution is there. If the color is not changing, means it is saturated with single bonds. So this is one of the tests for unsaturation. Okay. And when you are writing the color change, it is very important to write that orange or brown solution is going to colorless. Don't write clear. If you write clear, clear is not a right answer. Colorless and clear has a difference. So colorless is the right word over here, not clear. Okay.